When I started, it's only 30-something years ago, the reason people wanted to preserve materials was for money. Simple, plain and simple. Now there's also an awareness of the fact that if you can stop some steel corroding, you're not just saving money, you're saving energy, you're saving carbon equivalents. It's the sustainable thing to do. At various times I would have thought I was going to be a film director, a stage musician, a nuclear scientist, a physicist, a tribologist, and I've ended up being possibly a little bit of all of them.
For undergraduate studies, I did engineering materials technology, which was very new then instead of metallurgy. It introduced me to some of the problems associated with reinforced concrete, which led me to do a PhD in the passivation, which is the word protection of steel and its breakdown in concrete. From there, I did some postdoc placements for the Building Research Establishment and Transport Research Laboratories, and then went to work for the Atomic Energy Authority, essentially doing materials characterization and corrosion for what was then called the National Centre of Tribology. While I was there, I was approached to see if I would be interested in coming to work for Mott's to assist with the site phase of the Channel Tunnel. The thing about Mott's is that they'd long been involved in some incredibly interesting and innovative projects. There were tunnellers, there were bridges, there were reservoir builders. These were significant structures that required new approaches and challenging materials and methods to the very limit. And that's clearly a very exciting world to get into if you're involved in materials. The Silver Jubilee Bridge, it's a steel arch suspension bridge that crosses the Mersey River between Runcorn and Widnes. It was designed in the late 50s. If you were to look at the structure now, you'd notice that on the approaches, there is a joint above every third column. They'd been designed and built at a time when de-icing of the roads was not carried out. For the first few years, nothing. Then salting became common. Chlorides are definitely the Achilles heel of reinforced concrete. And as a consequence, every third column suffered very badly with the steel corroding excessively. The technique for dealing with it was to break out the damaged material and reinstate with a cement concrete repair. That doesn't work with chlorides. And so you keep having to repair it and repair it and repair it. And the only option is to either basically knock it down and build it again, or, as it turns out, use cathodic protection. Cathodic protection for steel and concrete was not unknown at the time, but it was rare in the UK in particular. It was very effective.
And cathodic protection is a surprisingly old technique. It goes back to 1824. It's taking the process of corrosion and taking control of it. In corrosion, you are essentially producing a battery. With cathodic protection, we take the item we want to protect, for example, steel and concrete, and we make it the part of that battery that is the cathode. The cathode does not corrode. What's the anode? The anode is either some metal that we put in there on purpose so that it is consumed instead. That's the traditional way, still used in many applications, or we provide the electrons the loss of that metal would generate. The great advantage of cathodic protection, particularly on structural use like reinforced concrete, is that you do not have to remove contaminated material, you only have to remove damaged material. And that's incredibly powerful in terms of saving time, money, and all sorts of things, less propping, less disruption to traffic and the like. And in fact, those piers are still repaired, and it's 30 years now, just about. When you think they were repairing them every 3 years, and they've gone 30 years and they're still fine, and we've seen no reason why they won't continue now for the 20 years, maybe another 30, who knows. When we extend that to steel frame buildings, of which there are a lot, from the sort of 1900s to 1930s in particular, the advantage that it does have is that we can leave most of it untouched.
When I was a young engineer, I did one of the biggest car park refurbishments in the whole of the UK, and we had to use cathodic protection, which is Paul's speciality. And Paul was such a technical expert, but also enormously good fun, and really sort of inspired me when I was a young engineer.
One of the great things about this fellowship is that it stamps the significance of what myself and my team do as being real. We really do have a fantastic matrix of abilities around there and experience that feeds into virtually every project that we do now.
Paul's a bit of a hero. His influence in the business and his willingness to just help colleagues has been fantastic. Paul's expertise is incredibly rare.
What we have been doing is to have structures CP ready. They are designed so that it can be applied more readily in the future should it be required. There's metro systems, there's tunnels, there's all sorts of things that now have that.
I think the most useful thing that we do is make what we've already got last.
I've met fantastic people, I work with amazing individuals, and I've been to some of the most unbelievable places, both in terms of countries and structures. And by gum, you'll go to some places nobody else can say they've ever been to. You'll go under things that people didn't know they had an underneath. You'll go on top of things that people didn't realise had a top. There is an awful lot out that is fascinating what we do and has value. In the end, that's all you ever want to really do, is do something that has value to yourself and everybody else. And I've been very fortunate in that respect.